Financial data integrity collapses when using simple flat lists because a single deleted record or a silent update invalidates the entire balance of your system without leaving any trace of the error. Robust enterprise resource planning systems rely on the double-entry ledger schema to ensure every cent is accounted for by mandating that every transaction consists of at least two opposing entries. Every financial event starts with a journal entry header table, which captures the high-level metadata, including the transaction date, a unique identifier, and a reference to the source business process. The ledger entries table represents the atomic rows of your financial data, linking back to the journal header through a foreign key to maintain a strict one-to-many relationship for every movement. Define your accounts table with a primary key identifier and a unique alphanumeric code to allow system analysts to categorize every business value and enable fast indexing during complex financial queries. Assign each account a specific type, such as asset, liability, equity, revenue, or expense, to determine how the application will treat the data when generating balance sheets and income statements automatically already.
Use the decimal data type with 19 digits of total precision and 4 decimal places for all currency columns to prevent the rounding errors inherent in floating point math from destroying your totals. Store amounts in a single column using positive and negative signs to represent debits and credits, which greatly simplifies the logic for calculating the total trial balance with a simple sum function. Implement a database-level check constraint or a trigger that validates the sum of all ledger entries within a single transaction identifier to ensure the total is always exactly 0 before committing. Apply a composite index on the account identifier and the transaction date columns to ensure that generating account statements and general ledger reports remains fast even as your table grows to millions. Financial ledger records must be immutable, so you should strictly forbid any update or delete operations on the ledger table to preserve a perfect audit trail of every historical transaction ever made. When an error is discovered, you must create a new reversing transaction that negates the original entry, rather than modifying the past, which maintains the transparency required for professional financial audits.
Use an adjacency list model with a parent identifier column to build a flexible hierarchy of accounts, allowing you to roll up small sub-accounts into larger consolidated parent accounts for reporting. For systems with deep account structures, add a materialized path column storing the full string of parent identifiers to allow for instant retrieval of entire subtrees with a simple like query. Incorporate international support by adding a currency code column to the ledger table and a separate reference table that stores daily exchange rates for all your supported foreign currency types. Always store the original transaction amount alongside the converted base currency amount to allow for precise reconciliation and to account for currency gain or loss due to exchange rate fluctuations over time. Enable granular analysis by adding dimension columns for cost centers and projects, allowing you to slice and dice your financial data without needing to create thousands of specific accounts in your hierarchy. For enterprise-scale systems, move dimensions into a dedicated many-to-many link table to support an unlimited number of attributes for every transaction without bloating the core ledger entry schema. Generating a trial balance requires a recursive common table expression that sums all entries for an account and its children to provide a consolidated view of the current financial position. Calculating balances from the beginning of time is inefficient, so you must implement a balance snapshot table that stores the ending values for every account at the close of each fiscal period. Implement a soft closing flag in your period table to prevent users from posting new transactions into months that have already been finalized and reported to the tax authorities. A hard close process involves zeroing out all revenue and expense accounts and transferring the net balance into the retained earnings account within the equity section of the general ledger. Use row-level locking and short-lived database transactions when inserting ledger rows to prevent race conditions from creating an unbalanced state when multiple users post entries at the exact same moment. Every ledger row should include metadata for the creating user and the system module identifier to allow for detailed forensics when investigating suspicious entries or technical bugs in the application.
Link your journal headers to original business documents using a polymorphic relationship column that can store the identifier and the type of the source record, like an invoice or a payroll entry. Separate high-volume data, like inventory movements, into subledgers to keep the general ledger clean while maintaining a summary control account that keeps the primary financial statements in balance. As the ledger entries table grows into the billions, use horizontal partitioning by date to ensure that active data remains on fast storage, while historical data is moved to cheaper secondary disks. Create materialized views for common reports like the income statement to provide instant response times for management, while the heavy aggregation work happens in the background after every significant batch update. Schedule a recurring database job that verifies the zero-sum invariant across the entire ledger and alert system administrators immediately if any historical record becomes inconsistent due to hardware failure. Use globally unique identifiers for ledger entries if your system requires distributed rights across multiple regions, or stick with big integers for the best performance in single-region database architectures.
Design a specific transaction type for foreign exchange adjustments that accounts for the difference between the transaction date exchange rate and the current reporting period rate to keep your books accurate. Avoid storing tax calculations only in the source document by bringing the tax amount and the tax jurisdiction code into the ledger entries to enable simplified regional tax reporting from a single table. Establish a clear archiving policy that moves ledger records older than 7 years into a compressed cold storage format, while keeping the period snapshots available for long-term trend analysis by the business. Validate your double entry schema by running edge case tests, including multi-currency splits and partial reversals, to ensure that no possible business scenario can ever lead to an unbalanced general ledger state. Architect your reporting queries to use effective dates rather than entry dates to allow the system to generate financial statements exactly as they appeared on any specific day in the historical record. To prevent deadlocks, always sort account identifiers in a consistent ascending order before acquiring locks during a transaction to ensure that concurrent processes do not wait on each other in a circular chain.
Even with decimal types, minor rounding differences occur in complex allocations, so you must define a specialized rounding account to capture these tiny fractions and maintain the zero-sum invariant. Never use a deleted at column in your ledger table, because queries that forget to check for the flag will produce incorrect financial results and destroy the user trust in your reporting data. As business requirements evolve, you may need to version your schema by adding an entry version column that tells the application which calculation logic to apply for historical versus current ledger records. For massive batch imports, disable non-essential indices and use native bulk loading tools before rebuilding the indices to minimize the time the database spends in a locked or high load state. Support multi-entity organizations by adding a company identifier to every journal and ledger row to allow for the generation of consolidated statements across different legal subsidiaries within the same database. While the database enforces the final balance, your application programming interface should perform preliminary checks to provide immediate feedback to users before they attempt to commit an unbalanced transaction to the system.
Add a full text search index or a dedicated indexed column for transaction descriptions to allow auditors to quickly find specific events using keywords without performing slow full table scans on the ledger. A meticulously designed double-entry ledger schema is the only way to build an enterprise system that remains accurate and trustworthy through years of complex operations and millions of financial transactions. By adhering to these rigorous architectural standards, you ensure your system analyst can handle any future requirement, from multidimensional reporting to real-time global financial consolidation, without re-engineering the core database.